You know, right now, this very second, data is literally flying through the air all around you. And I don't mean that as some kind of metaphor, I mean literally. Information is zipping through what looks like totally empty space just to get to your screen. So, how on earth does this invisible magic actually work? Let's dive in. I mean, really think about it for a second. You tap on a video and poof, it just appears. But there aren't any wires connecting your phone to the internet, right? So how does all that complex information make the jump? Well, that is the big question we're going to answer. All right, the whole secret to Wi-Fi, the absolute foundation of it all, starts with something you're already super familiar with, even if you don't realize it. Radio waves. They're basically the invisible highway that all of our wireless data travels on. Now, it's easy to think of radio waves as, some abstract concept, but they're not. They are on the exact same electromagnetic spectrum as the light you see with your eyes and even X-rays. They're just a different frequency. They are a real physical force that we've just gotten really, really clever at using for everything from your car radio to, of course, Wi-Fi. Honestly, the best way to picture this is to think of your Wi-Fi router as its own little radio station, just broadcasting away. And your phone, your laptop, your smart TV, they're all just tiny receivers tuned to the exact frequency that router is using. It's this constant two-way conversation happening all the time. So when you set up a new network and you see those options, 2.4 gigahertz and 5 gigahertz, those aren't just random numbers. They represent a really important trade-off. Think of 2.4 gigahertz as kind of like the long-distance runner. Its waves travel farther and are way better at punching through walls. But 5 gigahertz, that's the sprinter. It's much, much faster, but it has a shorter range, and yeah, it gets blocked more easily by things like walls and furniture. Okay, so we've got it. Wi-Fi uses radio waves. But how do you take something digital, like a file that's just a simple string of ones and zeros, and actually embed it onto one of these invisible waves? This is where the real cleverness comes in. The magic word you need to know is modulation, and this is the core trick of the whole thing. Instead of just doing something simple like turning a wave on for a 1 and off for a 0, your router makes these tiny, incredibly precise changes to the wave itself. It alters its height, or its speed, or its phase. These little changes are a code, and that code represents your digital data. It's basically how ones and zeros learn to speak the language of waves. It's just genius, really. So here's that whole journey laid out. It starts with the digital data on your computer, the ones and zeros. Then the router modulates a radio wave to represent that data. It transmits that encoded wave out into the air, and your phone's antenna catches it and just reverses the process, decoding it all back into the original ones and zeros. It's this little four-step dance, and it's happening billions of times every single second. Now, things get even more complicated when you realize it's not just one conversation happening. I mean, in a typical home, you've probably got phones, laptops, a TV, maybe a smart speaker, all trying to talk to the same router at the same time. Without some rules, it would just be total chaos. And that's the fundamental challenge of Wi-Fi, right? All of your devices are basically in the same room, shouting, hoping the router can hear them. To manage this, they just can't all talk at once. They have to share that airspace. And kind of like a polite conversation, they have to take turns. And here are those rules of etiquette, basically. Before any device even tries to transmit, it listens to see if the air is clear. If another device is already talking, it waits. If two devices accidentally talk at the exact same time, which is called a collision, they both stop, wait a totally random amount of time, and then try again. It's this incredibly disciplined and surprisingly polite system. But if all these devices are sharing and taking turns, that brings up a problem that I am sure we have all experienced. And it's one that engineers have worked incredibly hard to solve. We've all felt this, haven't we? You're home alone, the Wi-Fi is blazing fast. Then your family gets home, everyone gets online, and suddenly everything just slows to a crawl. Why does that happen? Well, the reason is actually pretty simple. Bandwidth is a finite resource. The best way to think about it is like a pizza. Your router has one pizza to share. If you're the only one eating, hey, you get the whole thing. But if 10 people show up, well, everyone gets a much smaller slice. More devices means less data per second for each one. So how do we fix this? Well, one super clever trick is called beamforming. Instead of the router just shouting its signal in all directions, kind of like a bare light bulb, beamforming acts more like a spotlight. It intelligently focuses the radio signal directly at the device that's asking for it. This is way more efficient and creates a stronger, faster connection. And if beamforming is like a spotlight, then MIMO, well, MIMO is a total game changer. Think of it this way. If bandwidth is a highway, older routers only had one lane. MIMO uses multiple antennas to create several lanes at once, letting the router send and receive multiple streams of data to multiple devices at the exact same time. This wasn't just a small improvement. It was a massive leap in how much our networks could handle. Okay, before we wrap this up, we need to tackle one of the biggest and most common misconceptions about how all this tech actually fits together. Here it is, the most crucial distinction. Wi-Fi is not the internet. I'll say it again. Wi-Fi is not the internet. Wi-Fi is simply the local wireless connection inside your house that links your phone to your router. That router, then, still needs a physical cable plugged into the wall to connect your whole home to the global internet. And here's the perfect way to really get that difference. You know when your internet provider has an outage, you might notice the little Wi-Fi symbol on your phone is still on. That's because your local network is fine. Your phone and your router can still talk to each other. The problem is that the router itself has lost its connection to the outside world. So let's put it all together one last time. Your request for data gets woken up into tiny packets. Your router then encodes those packets onto radio waves using modulation. Those waves fly through the air, your device's antenna picks them up, and then it reconstructs the original data. And all of this happens in the blink of an eye. And you know what? That is the perfect way to think about this. What really seems like pure magic is actually just incredible science. It's a system of controlled, polite, and mind-bogglingly complex radio conversations, all happening invisibly, all around us, all the time. Pretty amazing, right?